This is our second lecture in the last lesson, evolution of stars. In previous video, we learned that how the stars are formed from the interstellar clouds, how they take the form of the stars from the few light years big interstellar cloud. Okay, so in this slide what you can see, it shows you that after forming the star, after that what happens to the star. Okay, the star is formed from the interstellar cloud, that is nebula. It forms a main sequence, that is the main star. It remains in the universe for few billions or million years depending on its size, and then it goes through the various changes. That is, if it is the smaller sun, as small as sun, or if it is a smaller star, as small as sun, or little bigger than the sun, then it forms red giant. After red giant, it forms the planetary nebula, means small explosion takes place, and then finally it forms the white dwarf, that is the end stage of that star. If the star is very big as compared to the sun, then it forms the red supergiant. After that, the supernova explosion takes place, and again depending on that, if it is little only bigger than the sun, then it will form the neutron star. But if it is huge, very huge, means 25 times of the sun's mass, if it is so big, then it forms the black hole. So let us see this evolution of stars, how the stars go through these steps. We will see one by one. So first of all, we will understand that how the changes are taking place. What is the reason the changes are taking place, that we will first understand. Okay, we have been using this term evolution of stars. So first of all, let us understand what do we mean by evolution of stars. For a second, just keep the science aside and think of English, and what do we mean by the term evolution. What is the literal meaning of evolution? Evolution is the change. Okay, when we use the term evolution, we want to say it is a change. So when we are saying evolution of stars, at that time we are referring that from the time the star has formed from the interstellar cloud till it achieves its last stage, whatever changes it follows, that is called as a evolution of stars. Okay, so if I want to define evolution of star, it can be defined as the changes in the properties with time resulting in its passing through different stages. It is called as the evolution of stars. Means just now I explained you from the interstellar cloud to the sequence star, then to the red giant or supergiant, then the explosion supernova, and then finally the if it forms the white dwarf, neutron star, or the black hole. So this particular changes, this particular journey of a star is called as the evolution of star. Okay. Now, does it happen at once? You may have it in your mind. Then what will happen to the sun? If sun will also come to the end stage, then what will happen to us? So all these questions will be answered now. Okay. As we have discussed initially, till now more 4.5 billion years are there for the sun to come to its last stage. Okay, the reason behind that, the evolution of stars takes place very slowly. Okay, it is a very slow process, so it takes many billion years. So now the sun is in its middle age. 4.5 billion years are passed and more 4.5 billion years are still there. Okay, so don't worry. Fine. Then now when the star is going through all these stages, at that time it is continuously emitting the energy. Okay, when the energy will be emitted, now we get the energy from the sun, na? We always say heat of the sun, we use the heat of the sun. So when this continuous energy is emitted by the stars, at that time their energy is constantly reduced. Okay, their energy is constantly reducing. And just now in a previous point in the last video, we have learned that if stars has to be stable, then they have to maintain the two pressures. That is the pressure which try to spread the gas and the gravitational force. And when both the forces are balanced, when the temperature is constant, when the temperature is high. So for the stability to remain intact, for that balance, the gas pressure and gravitational force has to be equal, and for that forces to be equal, the temperature has to remain constant. Now what is happening? We are saying that the stars are emitting energy. Then how, and as they are emitting energy, the temperature will decrease. Then if the temperature is going to decrease, then how the star will remain stable? The star remains stable because the star keep on producing the more energy. The temperature remains constant because the star keep on producing more energy. So how does the star produce energy? The star produces energy by using its fuel. That also we learned in the previous lecture, that in the stars 4 hydrogen atoms combine together, that is nuclear fusion takes place to form the one helium, isn't it? So due to the nuclear fusion, the energy is liberated and the temperature remains constant. Okay, and as the temperature remains constant, both the forces, that is the pressure of the gas and the gravitational force, both the forces remain constant and the star remains stable. Okay, then continuously this fuel is being used, isn't it? Continuously temperature has to be maintained, na? So continuously this fuel is being used. So when this fuel is being used, then not now but after few billion years, this fuel is going to get over, isn't it? The fuel is decreasing and decreasing and decreasing, and one fine day, maybe after few billion years, that fuel is going to get over. So when that fuel is over, at that time the energy generation will stop, and when the energy generation will stop, the temperature of the stars will start decreasing. Now the temperature cannot be maintained because there is no fuel, there are no hydrogen atoms remaining to combine to undergo the nuclear fusion, and that's the reason the temperature will start falling. Okay, now due to decrease in temperature, what will happen? The pressure of the gas will also decrease, and as that pressure of the gas will decrease, the balance between that two forces is not there now. Pressure is less, gravitational force is more, and because of that, what is happening? Now gravitational force is higher. Due to that, gravitational force means what it is doing? Pulling it towards the center. So because of that, the star starts contracting. Okay, the star starts contracting. It is no longer stable now. It starts contracting. Okay, it undergoes the contraction, and now the particles are come closer and closer because it is contracting. So as it is contracting, the particles are coming closer. Because of that, what happens? Now higher fuel start burning. Okay, now hydrogen is over now, but helium has formed now. So now what will happen? Because it has come closer now, that helium atoms, they will start undergoing the fusion. Okay, higher fuel, the fuel with a higher atomic number will start fusing together. Okay, and because of that, now again the energy generation will start. Now again the energy generation will start, then again it will expand, and as it will expand, it will again both the forces, pressure of the gas and pressure of the gravitational force, they will again be balanced, and again the emission of energy will go on. But again one fine day will come when that helium also will be over. So that way, as many number of higher elements are present, that much time the star will remain shining. And when all the fuels are exhausted, when all the fuels are exhausted, at that time energy generation will completely stop. That will stop, the temperature will start dropping forever, and then the end stage of that star will come, because there will be no balance of that both the forces. Okay, and when there will be no balance of that forces, the end stage of the stars will come. Okay, now how the end stage is there? What is the end stage? So higher the mass of the star, faster the rate of evolution. Okay, what we said, that evolution takes slowly. But if the mass of the star is higher, the evolution will take place comparatively faster than the smaller stars. Okay, we said now when all the fuels are over, energy generation is stopped completely, temperature has started falling down. Now the star, because the star has stopped producing energy, now there is no pressure of the gas, so gravitational force will increase and star will finally start contracting, and there is no other fuels are remaining now to expand it again. So it will go on contracting and contracting. Okay, and because of that, what is happening, that the mass is remain that much only. Okay, the mass of that star is that much only. The particles which are there, that is that much only. But the size is decreasing, volume is decreasing, and because of that, mass upon volume, mass is that much only, volume is decreasing because star is contracting. So because of that, density will increase a lot, and the density will become so high that because of that high density, now some new type of pressure will be generated. Okay, because of now this new type of force or pressure which is generated, it is independent of the temperature. Okay, like previous pressure of the gas, it needed that temperature to become constant. Here that pressure will be this pressure is generated as a result of this high density. So it is independent of that temperature. Okay, and now when this new pressure has been generated, at that time that pressure will remain constant, even there is no generation of energy, even the temperature is going on decreasing, then too that pressure will remain constant, because it is not due to the temperature, it is due to the high density. Okay, and after this point, after this new pressure is generated, after this point, the stability of the star will remain intact. Means that stage, the stability of the star will remain intact, and when this stability remains intact irrespective of its temperature, then it is called as the end stage of the star. Okay, when that happens, it is called as the end stage of the star. Now, the end stage of the star is based on how big, how much is the mass of the star. The three categories the mass is divided. Okay, one is the mass of a star is 8 times smaller than the mass of the sun. Okay, the mass of a star is less than 8 times mass of the sun. If that is the mass, then what happens to that star? What is their end stage? What changes they undergo? That we are going to understand. Okay, in three categories we are going to understand. So first category is the smaller stars, which may be as big as the sun or even smaller than the sun. Okay, so what happened to them? These stars, they undergo expansion. When they undergo expansion, when they are becoming the star to red giant, so these stars, when they have gone, their energy production has stopped. At that time, these stars, this group of stars, they undergo huge expansion. The expansion will be as big as 100 to 200 times of their own radius. Okay, and at that time we call them as a red giant. Okay, means that star which was there, it is now formed into the red giant. Okay, red giant because they have expanded 100 to 200 times to their radius. Okay, and at this stage the star look reddish due to lower temperature. Now you may think that how teacher is saying why because of lower temperature they are looking reddish. So I'll just give you an example. See, when the coal is burning, we can see the flame, we can see the yellow flames coming out of the coal. But when the fire is put off, but still the coals are hot only, but they are not as hot as when the fire was burning. At that stage, how you can see the coal? What is the color of the coal at that time? It is red because its temperature has decreased as compared to that flame, isn't it? So same happens with these stars also. First they are shining, they are emitting the light, but now as the temperature is decreasing, because the temperature is decreasing, they look reddish in color. Okay, so that's why we call them as a red giant. Okay, at the end stage of this evolution, now after when the red giant has formed, and after that what happens? Star explodes. And their outer gas envelope is thrown out. Okay, whatever is outer gas envelope is there, because of the explosion, that is thrown out. Okay, and what remains inside, that part again starts getting contracted. Okay, it starts getting contracted, and because of that contraction, their size become as small as Earth. Why I am saying as small as Earth? Because they were at least sun size or maybe 8 times than the sun size. But now, because their explosion has taken place, outer gas envelope is thrown out. Now they have contracted to the size of the Earth. Okay, means what? Now their mass is quite high. Okay, but size is so small as of Earth. Because of that, the density is very high. Density of the stars are very high. And then at this stage, because of the small size, high density, the new type of pressures are generated. Okay, and this new type of pressure which are generated, they are due to the electrons in the star. Okay, they are not because of any other atoms, but they are due to the electrons in the atoms of that gas. Okay, and because of that, that is independent of the temperature. As I had explained you, at that time, because of the density, they have been arised, and so they are independent of the temperature, and their gravitational force is balanced due to this new type of pressure, and now the star is balanced forever, even though the temperature is falling down, and now it is cooled down more, and that's the reason now that red color was there, now it looks white. Okay, as they are smaller in size, they are white in color, so they are called as a white dwarf. Okay, these white dwarfs is the end stage of these smaller stars. Smaller means they are not very small, but they are small as compared to other huge stars. Okay, so the stars which has the mass less than that of 8 times of the mass of the sun, their end stage is the white dwarf. Okay, now let us see the second type of stars. Okay, second type of stars whose mass is ranging between the 8 times of the mass of the star to the 25 times of the mass of the star. In between their mass is their sun. Okay, now these stars, they go through the red giant. They also first form the red giant. After that they form the supergiant. Okay, supergiant means we say previous type of stars whose mass was less than 8 times of the mass of the star. Their radius was increasing 100 to 200 times. These type of stars whose mass is more than the 8 times of the mass of the star, their radius increases 1000 times. Okay, their radius increases 1000 times, and then when they expand so much, when their radius increases 1000 times, at that time a very huge explosion takes place, and this huge explosion is called as a supernova explosion. Okay, and it is so powerful that it lasts for few days. It lasts for few days. The light remains in that explosion for few days, and it is so bright that even in the daytime also we can see it if we are able to witness it. Okay, and because of this particular supernova explosion, lots of energy is given off. Okay, and then after that explosion, what remains behind is the central portion. Okay, now because the huge explosion has taken place, the lots of energy is emitted. Now what central portion is left behind, it starts contracting, and after contracting it comes to so small size as that of 10 kilometers. Only the radius of it remains only 10 kilometers. It becomes how huge it was. Its mass was between 8 times mass of the sun to 25 times mass of the sun, and now it has contracted so much that its size has become just as radius 10 kilometers. And because of this high contraction, now what has remained behind is only neutrons. In previous time we seen the pressure was due to electron. Here it is only due to the neutron, not even electron, and that's the reason this is called as a neutron star. Okay, pressure of this neutron is independent of the temperature, and it balances the gravitational force forever, and that's why these stars who have their mass between 8 times to 25 times of the mass of the sun, their end stage is the neutron star. Okay, and we come to the last type of stars who has their mass even greater than the 25 times of the mass of the sun. These stars also evolve like the previous one, like they first form the red giant, then they form the super red giant. Okay, red super giant, 1000 times their radius is increased. Okay, and then after very powerful supernova explosion takes place, and that supernova explosion is so huge that no pressure is capable of balancing this huge gravitational force. Okay, and because of that the mass starts contracting and contracting. It goes on contracting continuously. It is contracting, and because of that it goes on becoming smaller and smaller and smaller. Mass remains that much only, the size is becoming smaller and smaller. Because of that, the density has increased to a large extent, and then the density increases so much, and the gravitational force is so high that whatever object gets closer to it, it may be other star, it may be smaller stars I'm talking, or any asteroid, whatever, any object comes near to that star, at that time it gets attracted towards it, it gets absorbed in it because of the huge gravitational force. Okay, and nothing can come out, not even the light. When the light falls on it, the light doesn't come out because of the huge gravitational force. And as the light is not coming out, as the light is not reflecting back, we cannot see this star. Okay, because when we can see anything in the light, you have learned in the light lesson, when light falls on anything, when that light gets reflected and enters in your eyes, then you can see that particular object. Now here in this case, what is happening? The light is falling on that, but it is getting absorbed due to the huge gravitational force. Okay, and it is not coming back. Because of that, we cannot see it, and it looks like a minute black hole. That's the reason this particular stage is called as a black hole. So very huge stars end up their stage as a black hole. Okay, so this is how the evolution of the stars takes place. I hope it is clear to you. I know it is little bit difficult concept for you, but I have tried my best to explain you in an easier manner. I have broken down the information in a small points so that you will understand it. Okay, at the end I will summarize everything through the small presentation. Okay, from the time how the star forms till all these three types of end stages. So let us see that small presentation. So let us see how the changes are taking place. So here we are going to start with the interstellar cloud, a cloud of a dust and a gas. Okay, here in that there is in universe some changes take place, and due to that it starts contracting, and as it is contracting it forms the protostar. This protostar gets bigger and bigger because it is having the contraction. Okay, this was big, now it has become contracted due to some activities, and this gas and dust particles, they have started to come closer. As they come closer, then the temperature rises. As well as they are coming closer, the hydrogens are combining and forming the helium atom, and this process is called as a nuclear fusion. As a result of the nuclear fusion, energy is given out, so the temperature rises truly very high, and main sequence star is formed. Due to high temperature, there is an outward pressure of the gas, there is as well as there is an inward pressure of the gravitational force. At a particular temperature, both the pressures are balanced, and because of that the star remain balanced for many billion years. Okay, now finally some time comes when this fuel, that hydrogen, start to get over. It is about to get over, and when finally it gets over, and then the nuclear fusion stops. As the nuclear fusion will stop, the temperature will fall down. As the temperature will fall down, there is no pressure outside, pressure of the gas. So the contraction will take place. Then when contraction will take place, now what will happen? Second fuel will start burning. Again the expansion will take place. Okay, like that way it will go on as long as the higher and higher fuels are there. Finally, the time will come, all the fuels will be over. That time the end stage will start. End stage of the small stars forms the red giant, and red stage the end stage of the last star, bigger star forms the red supergiant. Okay, now what happens to this red giant and the red supergiant? We will see one by one. First, red giant. Red giant become unstable. It explodes and give out the external layer and form the dense small sphere, which is white in color, so it is called as a white dwarf. Okay, after this white dwarf, when it cools down, it turns black and it forms the black dwarf. In our textbook, that is not given. Okay, now let us see what happens to the red supergiant. Okay, red supergiant, in that case there are two cases are there. Okay, red supergiant, the stars with the mass between 8 to 25 times of the mass of the star, and the stars with the 25 times of the mass of the star. Okay, so the one which are whose mass is between 8 to 25 times of the mass of the star, they undergo supernova, that is the explosion. During this explosion they throw out external layer and they become as small as 10 kilometers in size. We've seen that. Okay, and finally the gravitational force increases so much that they form the neutron star. Okay, whereas the very huge whose mass is greater than 25 times of the mass of the star, what they do, they get contracted so much, the gravitational force increases so much that they do not allow any object to come out, not even the light. And that's the reason, as the light is not reflecting back, we call it as, we cannot see it, that's the reason we call it as a black hole. Okay, so once again, at a glance, dust and a gas, interstellar cloud, something happens, forms the protostar because the contraction is taking place. Protostar forms because temperature is rising, it forms the main sequence star. Nuclear fusion is taking place, it remains for years, billion years. Then afterwards, when the fuel is over, they, depending on their mass, they form the red giant or red supergiant. Okay, then red giant was converted to white dwarf after the explosion, and finally black dwarf. Okay, and super red giant, after supernova explosion, it forms the black hole, which does not allow anything to come out if the star is very big, and if it is a little smaller, it forms the neutron star. So here we have finished the lesson and the syllabus.